a grading form, the link for that, and also the student evaluation form. And also I will post, is your faculty advisor here?
I checked and I don't see him, but I sent him an
Okay.
email inviting him. I did.
Okay, okay. I mean, that's okay. He can access the recording later. Miss Norden is recording.
Okay.
Um, and yeah, the student evaluation, the evaluation team, please fill, okay? And anything else? And I will post the link to our senior design website so that you can give that to your faculty advisor to access your presentation. Okay.
Okay.
Yeah,
Mhm.
so that's important thing because he needs to review your slides.
Yes.
Yes. Yeah, that's all from me, and you can start your presentation now.
Yeah.
Okay. Hey, we are Team Endeavor. My name is Alicia Gobbold. I'm a computer engineering major. My role is being the team's leader, turning in our assignments, building our website, ordering our parts, and helping build the software subsystems.
Hi, I'm Yasin Simpson. I'm a computer engineering major, and I'm the software development lead for this project.
Hello, my name is Anthony Lee. I'm majoring in electrical engineering. On the project, I'm working on the DC motor mount, and I help with the power.
Hi, I'm Tyler Woodbury. I'm a computer engineering major, and I help with the hardware and software aspect of our project.
Hello, I'm Rashad Williams. I'm majoring in electrical engineering, and I work with both the hardware and the power side of this project.
Our team faculty advisor is Dr. Ali Gerbuz. He's an assistant professor in the ECE department. He got his PhD at the Georgia Institute of Technology in 2008. He's the co-director of the Empress Lab on campus. His interests include machine learning, computational imaging, and compressive sensing. Today, we'll be introducing the device that our team is designing called OvenMax, whose intention is to provide convenience to those who, like us, forget to turn our ovens off sometimes. The outline of our design starts with problem and solution.
Let's start by discussing the problem that OvenMax addresses. According to the NFPA, unattended cooking was the leading cause of all cooking fire. 1/3 of the people was killed by cooking fire because they were either sleeping or they forgot that the oven was on. The number of people with Alzheimer's is increasing and projected to rise 14 million cases by 2050. Upgrading comes into smart oven would be very expensive when smart ovens are $1,000 plus per oven. To solve these issues, OvenMax intends to offer some of the same functionality as smart oven while being cost efficient. Because many people buy smart oven for the safety features, OvenMax is designed to confirm the following design constraints. The OvenMax had the ability to connect to Wi-Fi, and also we designed our device to have a user account so that the user would be able to pair with his or her device through their smartphone or laptop. OvenMax power cannot exceed over 16 amperes at 120 volts. We designed a mechanical arm that turns off the oven while the user is away. We also provide environmental casing that will protect our devices from stove-top hazards like hot water, steam, other things that could affect the performance of our device. OvenMax provides a push notification to the user phone or laptop to remind the user of the time and any warning that the user should be aware of. OvenMax has its own oven control timer, which helps prevent house fire, and OvenMax will cost around about $200, which is very cheap compared to buying a smart oven. Our product is very reliable because our device will shut down and work properly even if it disconnects from the network. In addition to our constraints, OvenMax follows these engineering standards. We use IEEE 802.11 as one of the standard documents to specify Wi-Fi connection and notification. Our second document we use is the NFPA 70 to get the table for our power constraints for the kitchen. The last document we decided to use is the IEC 60529 to integrate protection against dust and water particles.
The hardware. The hardware breakdown will be explained in the flowchart. The power supply is connected to an outlet. The power supply in turn powers both the DC motor and the Raspberry Pi. Our device has a control where it controls both the Raspberry Pi. The Raspberry Pi has the capability of controlling the DC motor and the motor at the same time. It has the capability of controlling the DC motor, communicating with the application, and handling the input and output of the timer data. The following slide will show that in details. The power flow and the structural flow of the diagram. It shows how the conversion from the AC to DC starts with the diagram. The power coming from the outlet is AC going to the power supply. The power supply powers both the Raspberry Pi and the motor at the same time. It has the output at the top, with the potentiometer controls the amount of voltage coming out. So it can range from 0 to 5, as this project will do. And the input at the bottom where it has labeled L and N, which means line and neutral. The power supply then simultaneously powers the motor controller and the Raspberry Pi. The motor controller then powers the motor. Although the motor controls the motor, the Raspberry Pi controls the motor through the motor controller. Wiring. As in electrical engineering, this slide is the wiring we will use. We will use a 20 gauge wire. Why? Different gauges of wire have different electrical limits. A good electrical design will supply a reasonable amount of old current so that the dips in power do not affect oven max function. As a result, we decided to use a 20 gauge wire. It will best fit our needs since the current for a 20 gauge wire is 7.5, which is well above the oven max needs, which is just a little over 4. The USB-A side of the USB-C cord will have to be spliced, as you see at the top, so that the power can connect directly to the Raspberry Pi. The splice end, which is the top end, will be spliced so it will be able to connect with the terminals positive and negative. As you see in the last picture, the open wire will go into the top of the power supply. The encoder will connect motor controller to the motor. The branded side of the encoder will connect to the motor to finish the power flow, which have everything work smoothly.
Oh, is somebody muted?
Anthony.
Anthony, are you muted? Anthony, we're having some trouble hearing you.
He's not muted, but thankfully.
Anthony, is your volume down?
Who is going to present this part?
I think this is supposed to be Anthony.
Yeah, I think he got disconnected for some reason.
Oh, okay. Guys, while he gets reconnected, maybe one of you can pick up this part. How do you feel about that?
I will. Since it's working with the hardware side, I will. The purpose of the microcontroller is to act as the brain behind the device. It is able to purposely connect the data through the built-in wireless adapter. Also, it keeps the storage disk timer that is set by the user so the microcontroller can communicate not only to the application, but also to the DC motor. As soon as the amount of time set has expired, the microcontroller will send a signal to the motor controller to activate the DC motor. Lastly, it controls the LCD screen, which is going to be primary way to communicate with other Macs. When searching for a microcontroller, the number one priority for the team was to find one that is fundamentally familiar and easy to program, which is good for our team. The team also saw the opportunity to find a device that will be useful when it necessary to add features in the future. That's why these requirements on the table were chosen. The built-in wireless adapter necessarily mostly to avoid unnecessary hurdles, such as trying to find a wireless chip. The number of input-output ports was another requirement set. This will allow the addition of those further enhancements in future, like a solenoid that will push the off button in the digital ovens, which is very difficult. The final requirement will set overall cost of the device. The team needs to be very precise where the most of the money is spent due to our main goal of undercutting the smart oven competitors. In conclusion, the team decided to use the Raspberry Pi 4, which has an overall number of 40 input-output ports, built-in Wi-Fi capabilities, and a reasonable price of $35. Some of the team members have worked with the Raspberry Pi, like Lisa and Yasin, which are computer engineers in the past, so this provides an advantage when it comes to the software side of things. DC motor. If the
I think we
microcontroller,
have Anthony back. Anthony, is this your section?
Yes, ma'am. My internet just went out. I had to switch over to my hotspot.
That's okay.
okay,
Thanks for
Anthony,
rejoining.
I talked about the basically the introduction of the microcontroller. You can start talking about the DC motor.
All right. If the microcontroller was the brains of our device, then I would have to say the DC motor would be the bronze. The DC motor will be mounted and attached near the oven's controlling knob. Essentially, the DC motor will act as the rotational mechanism that will be used to rotate the oven's knob to the off position. After the user's set preferred time expires, the microcontroller will send the signal to the motor's controller, and the motor controller will determine the exact speed, direction of rotation, and when the motor will ultimately stop rotating. The rotation will cease when the motor is stopped by the already present safety mechanisms that most ovens have. For example, on a conventional oven, when a user switches the knob to the off position, it clicks into place, and the user will have to manually and physically press down on the knob again to set it back to the active. When considering the different types of DC motors, the team decided to focus on a few specifications and requirements. The weight had to be one of the most important factors when choosing which DC motor would be acceptable to use. A larger weight would lead to many complexities when figuring out how to mount the actual motor next to the oven's knob. Another important factor considered was the overall cost. Like discussed in the microcontroller section, the price needed to be reasonable, as a higher costing DC motor would increase the overall cost of the device, our device. Finally, the DC motor needed to be able to rotate 360 degrees. This is an important factor because the team needs the ability to rotate the knob without ever knowing the initial position the user has set it to. Considering the focus is on knob-controlled ovens, the 360-degree rotation will satisfy this requirement. All these specifications and requirements were met by the FIT0481 DC motor. It weighs a measly 18 grams, costs a minimum of $12, and has the ability to rotate 360 degrees in either the clockwise or counterclockwise directions. Moving on to the mount, it has to be one of the personal favorites among the many challenges thus far. It has given us obstacles such as figuring out a tool that would hold the actual DC motor next to the oven's knob. During the initial brainstorm, a partnership between someone in mechanical engineering or design was considered, but an opportunity never arose. It was then that the team had to sit down and start figuring out a plan on how to use already existing tools to help solve this problem. This leads to the idea that includes a windshield phone holder, a DC motor mount, and a C-clamp. The idea is to remove the top of the phone holder and to replace it with a DC motor mount. This will be done by welding the actual DC mount to the arm, to the adjustable arm. Next would be to attach the DC motor to the actual mount. And finally, the C-clamp would need to be attached to the DC motor. The C-clamp would then attach to the oven's knob, and the DC motor will rotate the C-clamp. The suction cup that is included with the windshield phone holder will give the user the ability to place and adjust the mount to any position that's most suitable for them. Another benefit would be the actual C-clamp. It will provide a little more stability to the overall mount. Now, what you're seeing is a basic representation of everything I just described. For example, the pencil sharpener, just imagine the pencil sharpener is the DC motor. And you can see that the pencil is attached to the C-clamp, and that will provide the rotation. And that's the basic idea of everything I was talking about.
Pretty early in our project's development, the team understood that a physical medium would be needed to allow the user to interact with and directly control their UpperMax. We pretty easily came to the conclusion that would have to be a touchscreen, since no additional peripherals would be required, which adds to UpperMax's ease of use. After all the controls that we allow the user to set are set, the touchscreen would then display the amount of time that the user has remaining, that the user's timer has remaining. Size was one of the most important factors in deciding which touchscreen we would use. The screen needed to be big enough that it was easy to read and use, but small enough that its weight didn't bring any additional concerns in mounting it, since mounting was already a big issue for us. This all led to our decision to choose the EllerCrow 5-inch Raspberry Pi touchscreen. It's not only directly compatible with the Raspberry Pi, but it's also very lightweight, weighing below the specified 16 ounces. The screen size would also be perfect for what the team's trying to achieve, with a diagonal screen size of 5 inches. The software side of our design is composed of 3 layers: the Raspberry Pi, the database, and the smartphone application. Though the design has these 3 layers, the user has the option of not using the internet side of the design at all, meaning that the Raspberry Pi can work as a standalone device. For full functionality, the database and smartphone app work together, though, with the Raspberry Pi to provide the user with a kind of remote control for their UpperMax. The combination of these layers forms a basis for the driving software that we need in order to properly manage the motor, timer controls, and user interfacing as a whole, both remote and local. On the Raspberry Pi, we chose the most basic operating system that offered a graphical user interface. From there, we'll be able to plug the touchscreen in after some setup that allows it to function properly. And then afterwards, we'll need to actually create the driver files and programs that implement all the control functionality that we need, being oven timer control limits, local alarms, timer controls and updating, and motor controls. Motor and timer controls are kind of natural extensions of what UpperMax is trying to achieve. Meanwhile, timer control limits are something that we had to come up with just by specifics of our design. And for example, the timer control limits exist to provide additional safety, and local alarms exist in place of the built-in oven alarm since it would not be set. Alicia, are you muted?
Yeah, Alicia, don't hear you.
Oh, I'm sorry.
Okay.
Our design also has a database that accounts for account creation for the users and giving them remote control of their device. Besides just storing user credentials, the database updates any changes that the user wishes to make. Any update on the database is then transferred to the app, which reflects to the Raspberry Pi that always checks the database for any updated changes. We created our app using Flutter. Flutter is a free toolkit that Google uses to help create both iOS and Android applications. By using this,
I'm sorry, Alicia, you got 2 minutes left.
By using this, we provide an extra layer of security to the users by making them create user accounts. When they create user accounts, it allows for any non-users to be able to have any control over anybody's UpperMax. UpperMax also provides a shutdown guarantee. A shutdown guarantee is provided in case the initial time that the user sets runs out, or any Wi-Fi disconnection. The user also is allowed to have push notifications on how often they want to be notified about their oven. Here's our team's progress so far. The only parts we have so far are our Raspberry Pi and our motor controller. By the end of the week, we plan to have all all of our parts, hopefully, to be able to get started on our prototype. So far, we only have the application in process because we were still waiting on parts as of the last few weeks. Overall, UrbanMax's main goals are to be cost effective, add precaution, and to add convenience. We appreciate your time and we're open to any questions.
First of all, I would like to open up for questions from the audience and the faculty.
I have asked my questions mainly in mostly our meetings. Thank you, guys.
Thank you.
Thank you.
Good job.
So have you started building your project yet?
No, ma'am.
Because
We're waiting on our parts. Alicia
Oh.
had just explained that because of the transition of the parts. Last week when he told us that they was in transit, they was just still in transit, and then the ice storm, so everything has just been slow behind. The only thing that we have started on or is completed, Yasin and Alicia, they completed the website, so that's basically in the application. So that's basically what we're doing. Anthony has started working on the hardware mounts. As for me, as in the power supply, we're still waiting on that to get in transit. The wiring and everything, we still haven't had that delivery yet. But it's not that hard to actually break down the wiring part that goes into the power supply that connects to the Raspberry Pi and the motor controller and connects to the motor. So whenever they get started, it shouldn't take long to build. So other than that, that's basically our whole process of the project.
Yes, we actually right before this, Shamin had sent out and said pick up parts. We don't know exactly which ones came in, so we have to check with him and pick those up. So hopefully everything
Yeah,
like our motor.
We'll have whatever parts we received in today. We'll now be able to take stock and we'll be farther along than this presentation shows.
so are you planning to use the lab for your project setup?
Yes, provided that they are parts that we can start with setup. Yes.
Yeah, I haven't seen your project setup when I visited 2 days ago.
Right. We did
Yeah,
everything
yeah.
right. The parts just came in. They came in yesterday, but that was tornado warning.
We're crossing our fingers for the DC motor. That's one of the most important. Just to-
Right.
For us to really get started on.
So how about the hardware part? I mean that the lever and all. Do you have it ready or?
Not yet.
Mhm.
That was just showing. That was I mean, of course, it was just like a basic generalization, but right now I'm just waiting on the DC motor to test, like if everything would work out, to see, because that's just a prototype. I want to see if the actual DC motor will do everything I'm thinking.
Mhm.
Have a theory of.
There's a couple more specifics to hardware before we can actually prototype accurately is the thing.
How about the phone app? Is anyone working on that?
Yes, me and
Yes.
Yasin are in the process of building the app while waiting on our parts.
So while waiting on the parts, at least you can do these things. I mean,
Yeah,
you know.
Yep.
we actually just have to go to the lab and see what came in because he emailed like right before this, so nobody's been able to stop by. But we'll pick them up before the end of the day and see what we have in and be able to. Hopefully, we're able to get started.
Guys, I wasn't sure, I may have missed it. I know you talked a little bit about it, but I may have missed what your solution was. So to turn the oven off, Anthony, maybe this was your part with your rig set up. How again is it going to turn it off? Is it going to twist it or is it going to like poke a button?
No, we decided to focus it on like a knob controlled oven so that it would be easier to like broaden out into like the stovetop. So it's going to be to rotate the actual knob to the off
Okay.
position. So
Yeah, and tell me again, Anthony, how is it going to know when it gets to the off position?
it when you turn on, like on most ovens, when you turn a knob, it'll click into place like when it hits the off position, and you have to physically and manually press down on it to be able to turn the oven back on again. So
Okay.
we were going to utilize that feature on the ovens.
Oh, good. Okay.
And where do you mount the display?
The display will be mounted directly to the Raspberry Pi, which we're expecting will be mounted on the wall behind whatever oven you got, just over the control panel of it.
Okay. So, Dr. Gurbaz, I posted the grading form in the chat box for the faculty.
Let me try to find it.
And the student evaluations, I posted the evaluation form for the students. And also the faculty, if you want to review their presentation, so you can find the presentation at this link.
The chat box. I'm not really familiar a lot with the Teams, so I'm trying to find the chat box.
On the top, next to the take control button. Okay, there is one. First one is the show participants, and the second one is the conversation.
Yeah. It should have a little orange dot on it.
Yeah, you can.
In my one, the first one is show participants.
Yeah,
and
second
one is some, I guess,
conversation. Hide conversation.
I mean, it shows something like I like it, something like those kind of things. More actions and more
I think
actions.
click more actions and scroll all the way to the bottom, and at the bottom you should see show conversation or hide conversation. You must not have Teams maximized. It changes the toolbar layout.
Of incoming dial pad, turn on live captions.
Very bottom, very bottom. It should say show conversation.
Is it possible? Why didn't I? Looks like I have meeting details, gallery, together mode, focus, full screen, apply background effect, dial pad.
Very bottom of that menu.
And turn off incoming video. That's the only things I have.
Oh.
Is there a way for me to copy it and like email it to him or something?
Yeah, that
if
would be great.
If it is possible, just email me.
Yeah.
Okay.
But this.
Yeah, Alicia, if you could copy the evaluation link for the advisors, and if you could also send him a link to your slides on your website, that would be great. So he can look back through your slides too.
Yeah, that would be great. Okay, and I can email those grading forms back to you, Lalita.
Yeah, just, I mean, if you open that link, Ali, fill it up and submit, it will come to me directly.
Okay then. Okay, perfect.
So.
Okay, that's great.
All
Thanks
right.
a lot. Good job, guys.
Thank you.
Keep up the good work.
Thank you.
Okay.
Thank you.
Thank you.
All right, guys. Well,
thank you for your time, Ali.
Yeah, you're welcome. See you.
See you.
All right, guys. Well, we need to wrap this one up so we can get into the Smart Cornhole presentation. Thank y'all so much.
Okay, thank you.
Thank you.